Namaskar. Now we are aware about scalar quantity, vector quantity, how these quantities can be represented. There are three ways of representation. One is the magnitude and direction. Second thing is the graphical representation, this is magnitude and direction, and then the component representation of the vector physical quantity. Then we have gone through how we can add the vectors. Okay, suppose we will have to add or subtract the vectors, then what are the methods for addition and subtraction of the vectors. We'll proceed for the multiplication. Before that, we can have three different terms. One is just a number. When we add unit to this number, then it becomes the scalar physical quantity. And when I add direction to this scalar physical quantity, then it becomes the vector physical quantity. Okay. For example, I can think about just a number, say for example 5, then I may say that it is 7, then it is 3, then it is 2, etc. These are just numbers, and we are aware about the arithmetic operations on the numbers. I can have 5 plus 7, 7 plus 3, 5 plus 7 plus 3, 5 minus 7. Yes, the subtraction is negative, minus 2. Then maybe minus 3, therefore it will be minus 5, then maybe plus 2, etc. We are aware about the product, that is 5 into 7 into 3, 7 into 3, etc. We are aware about the division too, that means 5 divided by 7, etc. These are the operations on the numbers only. Suppose if I say that the weight of a person is 57 kg, then this is the scalar physical quantity, correct? We have added the unit, therefore it has certain meaning. It is not just a number 57. And with this also we are aware about how to add the numbers, how to subtract the physical quantities, not number only, scalar physical quantities. And for that our restriction is that to have the addition and subtraction, the unit must be same. Last session also we have observed that 5 bananas plus 3 mangoes, I cannot add them together. It remains 5 bananas and 3 mangoes. But here suppose it is 57 kg plus or minus 32 kg, then it is meaningful. I can say that it is 89, or if I subtract, then it will be 25. The unit remains constant, it is kg. It is fine. If I think about the division, then it is also fine. It is 57 kg divided by 32 kg, and that will be just the ratio of 57 divided by 32. In case of the multiplication also we are aware about such type of multiplication. Here I can say that resistance is there, and I can say that suppose it is 1000 ohm, it is resistance, into there is a current of say for example 5 ampere, and therefore you may think about it is 5000 volt, correct? It is the multiplication, and obviously 5000 volt divided by 5 ampere current will be the 1000 ohm resistance. That means we are aware about the addition, multiplication and division related with the pure numbers as well as the scalar physical quantities. Sometimes beginning from the school level itself, we had a practice to write it is 5 into 7, correct? This is, and obviously we were thinking about this is the just a product between 5 and 7, and therefore we were aware about that. This 35, etc. Fine. If we will have to have some multiplication and if possible division up to certain extent with the vectors, then we will have to have some definitions. We should go through the definitions. What type of products are possible? Now I am not using the word multiplication, but I am using the word product. I have three quantities: number, then scalar, and then vector. Therefore there are different possibilities. I can have the product between number and number. We are aware about this. I can have the product between scalar and scalar. I am aware about this, it is scalar and this is scalar also. Similarly for the division also, this is the division. But we are not aware about the involvement of vector in it, correct? Vector in it. And therefore, now what are the remaining possibilities? One, it is possible to have the number into vector, correct? Into vector. But you can point out that I have not mentioned any symbol in between the number and vector, just I am keeping them in bracket. The reason is that actually you are aware about that. At some 11th you have gone through the dot product and cross product. Therefore these are the typical symbols. This is for certain product between two vector quantities, we will define later on, and this is also to represent certain type of product between vector quantities. And hence now onwards it is not proper to write this 5 cross 7. This cross has a certain meaning in vector product only. Therefore, if I will have to write this 5 and 7, just I will have to write 5 into 7. And this is simple product. This is known as a simple product. It is multiplication, simple product between these two. Okay. Now, what is possible? It is number into vector. Obviously, number into scalar, we have already done. Suppose if there is 2 kg and I will have to repeat this for 2 times, then 2 into 2 kg, I can say that it is 4 kg. And we are aware about that. But number into vector we will have to discuss. Then we will have to discuss something about scalar into vector, product between scalar and vector. We will have to check, is there any symbol here, is there any symbol here. And then we will have to think about vector into vector, correct? Vector into vector. Now among these two, again we may be familiar about these two types. And we are. See, when we discuss something about magnitude and direction representation of a vector, there we have observed that A bar is A cap. That means A cap is a vector and I will have to repeat this A times. Therefore, this is purely number, or it may have, yes, it is purely number. It has no unit. And therefore, here I can say that suppose it is 5 into A bar, then that is nothing but I will write it is 5 into A cap, or that is equal to 5A into A cap. Means when I multiply any vector by a number, it indicates that I will have to multiply the magnitude of that vector by that number and direction remains as it is. Correct? Okay, this is fine. What about this? We are also aware about such type of multiplication. For example, suppose if I think about it will be force. Force is equal to mass into acceleration. Therefore, here it is A bar is the acceleration. Convention is to write the small a and therefore I have changed this. It is mass into acceleration. Mass is a scalar quantity and acceleration is the vector quantity. But here the scalar quantity has a unit. Therefore, here what is situation? It is 5 kg into 2 meter per second square. And the answer is again I will have to think about the product between two magnitude terms. Therefore, it is 10. Then I will have to write kg meter per second square. I will have to combine the units together, that is kg into meter per second square. Therefore, we are aware about this type of product too. Again, we will have to note that there is no dot. Now, it is our practice to write some dot or such type of cross, but now onwards the dot and cross may have different meaning and therefore we will have to avoid that type of representation. But when I think about a vector and vector, then we will have to define two types of products. There are definitions. Now, what is the meaning of definition? We will have to define something. For example, I will let you know what is the definition for that. Between two vectors, two types of products are defined. One is that A and B, this is A bar and B bar, and it is represented as it is AB cos theta. It is defined as AB cos theta. Therefore, let's assume that A bar and B bar are two vectors. Then, if I take a product between them, then the result will be AB cos theta. A is the magnitude of A bar, B is the magnitude of B bar, and cos theta is the angle between them. Now last time I have mentioned that. Okay. Sorry for some interruption during recording. But now we have defined A bar dot B bar as A B cos theta, where A is the magnitude of A bar, B is the magnitude of B bar, theta is the angle between A bar and B bar. Therefore, we will have to take cos theta and then take simple product among A, B and cos of theta. This is known as the dot product or scalar product. The resultant of product of two vector is a scalar quantity, therefore it is known as scalar product, and it is represented by dot between two vectors, therefore it is dot between two vectors, therefore it is known as dot product. In vector product, if I take two vectors A bar and B bar, if it is defined as A B sine theta with certain direction. Now what is the direction? The direction is perpendicular to both A bar and B bar. Therefore, we will discuss on the direction later on. But the product is defined as A, B and sine of angle between them. Therefore, this term is the scalar term. This is the direction of this scalar. Therefore, resultant is vector and hence it is known as a vector product. And how it is represented? It is represented by cross in between A bar and B bar. And therefore, it is known as cross product. Now, last time we have observed that it is no meaning to write the dot between or cross between the 5 and 7, or there is no meaning to write cross also. It is better to write it as 5 and 7, something like this. The reason is that the dot product should be in between two vectors. The cross product should be in between two vectors. Now what is n cap? N cap is the direction which is perpendicular to both A bar and B bar. Now when we discuss the right-handed Cartesian coordinate system, there we will give the stress on this. But typically I can say that suppose this vector is A bar, this vector is B bar, and if I take a product A bar to B bar, then the resultant is perpendicular to both A bar and B bar. Therefore, this can be treated as the vector C bar, which is A bar cross B bar, whose magnitude C is A B sine theta and direction C cap is given by n cap. The n cap is the direction, which is nothing but the direction of resultant. Okay, sorry for interrupt. Now we shall proceed further. Here we have defined the vector product as A bar vector product B bar is A B sine theta. Theta is the angle between A bar and B bar. Here also in scalar product, cos theta is not angle but theta is the angle. While defining this dot product, I have mentioned that cos theta is the angle, but cos theta is not angle. Theta is the angle between A bar and B bar, and we will have to take a cos of theta, and then we will have to take product of A, B, cos theta. Similarly here, theta is the angle between A bar and B bar, and A, B sine theta is the magnitude part of the product which we are going to define, and n cap is the direction. Now as the resultant is the vector quantity, it is magnitude and direction form, it is known as a vector product, and as it is represented by the cross between A bar and B bar, it is known as cross product. Therefore, this is cross or vector product. A bar cross B bar is equal to A B sine theta n cap. Now why I am calling it is defined as. Now you may define your own product. Say for example, my name is Bhide and therefore I can say that let we define the Bhide product between two vectors A bar and B bar. And instead of having cos and sine, I will use tan theta. And if I think about this to be the scalar product, I can say that A B tan theta is Bhide's product. Yes, we can define. But it will not survive. The reason is that there is a very famous principle of Darwin, survival of fittest. If it is useful, then it will survive. The Bhide's product, if I define, then I will be knowing that A, B, tan theta is the BD product, but it has no physical significance. And as it has no physical significance, it will not survive. No one can use that product. There will not be any physical situation where we need that particular product. That product has no specific meaning, and therefore in due course no one will use that and it will die automatically. But these two products, that means the dot product, or it is known as a scalar product, or cross product, it is known as a vector product, they are meaningful. They have certain meaning. Now what is the physical significance we will discuss later on. But before that, we will try to find the product if the vectors are represented in their component form. Okay. Now see, when I think about the vector A bar is represented in magnitude and direction, then it is useful because A is used as a magnitude. For B bar, B is the magnitude, and if theta is the angle between A cap and B cap, this is angle between them, it is theta, then we will have to take cos of theta, and therefore if the vectors are in magnitude and direction form, then it is useful, but we will have to give the angle between them. Similarly here also we can say that A is the magnitude of A bar, B is the magnitude of B bar, theta is the angle between them, and I can find the cross product between these two vectors. But what happens if the vectors are expressed in their component form? Here typically I can write, if I will have to write A bar dot B bar, then I will write A bar means it is AX I cap plus AY J cap plus AZ K cap, and then the dot product with another vector, that is B bar, it is BX I cap plus BY J cap plus BZ K cap. Now using the property of distribution, what I will have to do, I will have to write AX I cap dot BX I cap. But now AX and BX are only the magnitude part, and therefore I can write it is AX BX I cap dot I cap. Similarly I can write it is AX BY I cap dot J cap, and I will write it is plus AX BZ I cap dot K cap. And I will continue. Now as a homework part you can do this. AX I cap dot BX I cap, that is AX BX I cap dot I cap. AX I cap dot BY J cap, it is AX BY I cap dot J cap, and so on. And you will realize that for I cap dot I cap, the angle between I cap and I cap is 0, therefore cos of 0 is 1, and just it is I, but the magnitude of unit vector I cap is 1. Magnitude of unit vector I cap is 1, therefore 1 into 1 it will be 1, and it remains AX BX. But for I cap dot J cap, angle between I cap and J cap is 90, cos of 90 is 0, and therefore this will be 0, therefore AX BY into 0, this term will vanish. Similarly for AZ, AX BZ, same thing will happen for AY BX, AY BZ. But what happens for AY BY? For AY BY, there will be J cap dot J cap, which is equal to 1, and hence that term remains as it is, therefore this will be AY BY. Remaining two terms, AY BX J cap dot I cap will vanish, AY BZ J cap dot K cap will vanish. For AZ K cap, AZ BX K cap dot I cap will vanish because angle between I cap and K cap is 90. AZ BY K cap dot J cap will vanish because the angle is 90. But AZ BZ K cap dot K cap, and angle between K cap and K cap is 0, therefore cos of 0 is 1, and this term remains as it is, that is AZ BZ. Therefore, if the vectors A bar and B bar are expressed in their component form, then the dot product can be solved as like this. It is A bar dot B bar is equal to AX BX plus AY BY plus AZ BZ. You can realize that this is the scalar quantity, and therefore the resultant of A bar dot B bar, that is dot product, is the scalar quantity, therefore it is known as a scalar product. Now we will proceed for the vector product. Now, as it is defined, here it is defined like this. If they are in component form, then A bar cross B bar is given by a determinant whose first row is I cap, J cap, K cap. The second row is coefficient of A bar, that is AX, AY and AZ, and third row is coefficients of B bar, that is BX, BY and BZ. Now we have a practice to solve this determinant. What I will have to do, I will have to keep I cap as it is, and then I will have to write it is AY BZ minus AZ BY, correct? Plus I will write it is J cap into bracket, I will write AZ BX minus AX BZ, plus I will write it is K cap. I will have to hide this and take a product. Therefore it is AX BY minus AY BX. Now you might be focusing on this plus sign on Z. What we will have to do, we will have to hide this middle column and the first row. But while taking the product, instead of AX BZ, I have taken AZ BX first, and therefore this sign is plus sign. Now if you have any doubt, then try to solve this determinant by your own method, and you will realize that if you write here it is negative sign, then these two terms are flipping, but the meaning is same, and therefore this can be treated as the cross product. Now what is the physical significance of the dot product and cross product, and how we can solve some problems related on dot and cross product, we will discuss in the next video. Now you are knowing that the previous video was cut at a particular point, and therefore I have added this video for the previous one. Thank you.